Hi, today let's try to solve this problem, number of operations to make a network connected. So we're going to be given an array of connections. So each thing represents one edge, which is the connection made between one computer to the other. And we see, like in example 1, we see that 0, 1, 2 are connected and 3 is not connected, and we have to find the number of operations it will take to remove one edge and connect all the computers. So here if you see, they removed the edge 1 to 2 and connected it from 1 to 3. Now the complete graph is connected, so we have to find the minimum number of operations to connect all the computers in the network. Okay. So to solve this problem, one thing we already know is that the number of edges required to connect n nodes, it's going to be n minus 1, right? So here we have 4 things, we need minimum at least 3 edges. Here we have 1, 2, 3, 4, 5, 6, we need at least 5 edges. So 1, 2, 3, 4, 5. Okay, and once we have that, right, so if we figure out that the number of connections is less than n minus 1, then we can return minus 1 directly. And if that means it's not possible to connect, otherwise we can return, like here if you see, right, it's a number of distinct or number of groups minus 1. So here you can see there's one group, here's another group. Number of operations needed is just n minus 1, which is 2 minus 1. Here we have 1, 2, 3 groups. So the number of things to connect is n minus 1, 3 minus 1, which is 2. So one way to do this is by using the union find algorithm, which is used to find the number of number of groups within a graph. So we'll keep on connecting two computers as we iterate through connections, and at the end we'll have the number of groups present, and then we'll just return that minus 1. And initially we'll check if the number of connections is greater than we have to check if the number of connections is greater than n minus 1. If it's if it's greater than equal to n minus 1. If it's less than n minus 1, then we'll return 0 minus 1. Sorry. So let's start coding this. Okay, what we'll do is we'll find number of connections. Connections dot length, and if con is greater than, okay, if it is less than, so n is the number of computers, it should be greater than n minus 1, right? So here if we have just two things, number of connections 2, and we have n as 4, 1, 2, 3, 4, then 2 is less than 3, so we'll return minus 1. So suppose we have this, we have number of connections as 3 and we have n as 4. So is 3 less than 3? No, so we won't return minus 1. Okay, and now let's create a subclass, or you can create a separate class. We'll create a union find class. Here we'll have int n, we'll have int parent array, we'll have int rank array. Okay, and let's have a constructor public union find, and let's pass int n. This dot n is equal to n, and then we'll have let's initialize both these arrays as well. new int n, and yeah, and then let's initialize the elements in both of them. So for int I is equal to 0, I is less than n, I plus plus. Here for everything initially has a parent of itself. Okay, so let's just put, oh, I don't have the array. Okay, so yeah, of itself. So let's just put the index of I. So 0th element has a parent of 0, 1th element has a thing of 1, and initially let's initialize everyone's rank to 1. Okay, let's finish writing the methods also. So int find int x. So what I'm going to do is, if x is equal to parent of x, that means we found the root and it's going to be x itself, right? So we're going to return x. Else we basically have to find the parent of x. Okay, so we have to iteratively do that till we find the parent of x, and while we do it, we can also as we're finding it, we can initialize the parent to that itself, right? So let's just do, we can assign the parent of x is equal to find parent of x. And now what we'll do is, we'll do public void union int x comma int y. So if if count is equal to n is 1, right? That means there's only one group, one distinct group. So we don't need to do any union. Okay. Else let's find the parent of x. Let's find the parent of y. Okay, and once we do that, if parent of x is equal to parent of y, that means it belongs to the same, it has the same parent, so it's already belonging to the same group. Otherwise we have to union it. Not equal to parent of y. In this case, what we have to do is, let's compare the rank as well. So let's attach it to the longest tree. So if rank of parent of x is less than rank of parent of y. Okay, so y has the greater thing. So we'll make parent of x, parent of parent x is equal to parent y. Else if I copy the same thing, okay, if parent of x is greater than y, that means parent of parent of y, I mean this we are going to assign it to x. Okay, and now suppose the ranks are equal, then we can assign it to any. So let me just do the first one. Parent of x is equal to parent y, and that means the rank of y is increasing. Okay, and in this case, after we did a union, right, we are going to do count minus is equal to 1 because the count has decreased. And next, and distinct components return count. Okay, so this seems good. Now what I'm going to do is we have to iterate through connections. Okay, and do union pen. Union find, and let me pass n. Okay, so initially we're going to have all separate things, and while we're iterating through it, we have to connect every node. So what we're going to do is we're going to do uf dot union on I comma 1 I comma 0. So we're going to connect everything, and at the end I'm going to return uf dot let's try to figure out the mistake. Yep, initially I kept it here, so if parent of x is equal to parent of y, we're not going to join it, right? I mean the number of distinct things won't decrease. So that was the issue. Let me just submit and see if it works. Yep, looks like it worked fine. Okay, thanks everyone, that's it for today.